Hi there! I am going to tell you all you need to know about the concept of biofuels. I will mainly be covering the process based on this concept of converting organic material to biofuels. The one thing our Earth needs to keep sustaining itself is sustainability. And we all know our basics, the 3 R's: reduce, reuse, and recycle. But the issue, of course, is a whole lot bigger than that. Scientists have already discovered many new ways of being sustainable that people have started to implement. These include solar power, or energy from the sun, wind energy, harnessing the power of the wind, hydropower, energy from running water, and geothermal energy, energy that we get from the temperature of the Earth. But there's one more aspect we need to add to this equation, some kind of fuel. So we have biofuels. They are renewable resources, making it the perfect addition to our set of eco-friendly innovations. So meet Ali the algae, our assistant for the conversion. Hydrothermal liquefaction is a process we will use to decompose the algae. Using high temperatures and pressures, we can decompose the algae into its separate basic components. So Ali will now be put under high temperatures and pressure. But don't worry, she's completely prepared. She is now decomposed into 5 main macromolecules: cellulose, starch, both of which are carbs, lipids, lignin, and proteins. The basic macromolecules are broken down further so that the very simplest of molecules are left behind. So cellulose would eventually turn into phenols. Starch would turn into sugars. Proteins would turn into amino acids. Lignin would turn into individual hydrocarbons. Lipids would turn into fatty acids. The next part of this process is called fragmentation. It's when oxygen and other atoms are removed, leaving behind carbon and hydrogen atoms in the form of low molecular compounds. This is very useful to maximize the energy content of the biocrude oil. Next comes transesterification, which is the chemical reaction used for the conversion of algae to biofuels.
It is now time for terms.
You came across a few terms you probably haven't heard of before, so let me tell you a bit about what they mean. Firstly, we have triglycerides. They are esters formed from glycerol and 3 fatty acid groups. Triglycerides are the main constituents of natural fats and oils. Do you see the correlation now? Algae has triglycerides too, which are the same compounds that exist in vegetable oil, which means with some help, this can be transformed into biofuels. Next up, we have methanol. It is a toxic, colorless, flammable liquid alcohol made chiefly by oxidizing methane. Next, we have catalyst. It is a substance that increases the rate of a chemical reaction without itself undergoing any permanent chemical change. Next, we have glycerol, which is a sweet, syrupy liquid obtained from animal fats and oils or by the fermentation of glucose. And finally, we have methyl esters. It is a type of fatty acid ester that is derived by transesterification of fats with methanol. And guess what? The molecules in biodiesel are primarily fatty acid methyl esters. Now let us go back to the reaction and see how each of these terms have a huge role to play in transesterification. This is the process as a whole, but let's look at it step by step. First, we add the triglycerides. Then, to that we add methanol. This reaction needs a catalyst, so we usually use potassium hydroxide or sodium hydroxide. After that, you get glycerol and methyl esters. Now, we have the biofuels. Of course, there are a lot more technical details, but for this purpose, what we know is enough. Transesterification left lipids that can now be used as biofuels. The process of hydrothermal liquefaction may have looked simple, but when we dug into the specifics of the organic chemistry involved, it was actually complex. Speaking of complex, let's move on to the next section: complexity. Every issue has some aspects that make it complex, but a teacher of mine once told me that simplicity always lies on the other side of complexity, which is why I will explain some of the practical issues we may face when we make biofuels, along with the solutions. Issue 1. Availability. A question that might have popped into your mind is algae a renewable resource? Yes, it is, because in not so very technical terms, algae are plants. But where can we find algae? Algae can be found almost everywhere on Earth. In fact, a more appropriate question to ask would be, where don't the algae grow? There is a pond in my school where I decided to check for algae. Here is the proof that algae could even exist in a pond nearby. Issue number 2 is energy consumption. A big problem regards how much energy this process uses. Biofuel manufacturing is supposed to be an alternative to fossil fuels. We will touch on that later. But how much energy does it actually use? To be honest, making biofuels does require a lot of energy. But if we can transform the biofuel manufacturing industry to grow much larger in terms of both usage and efficiency, energy consumption will not be a problem. Now we move on to implications. The first implication is, of course, a more eco-friendly world. The advancement from fossil fuels to biofuels will result in a much better world, one without fear of depleting resources. The second implication is a rather far-fetched one, but it isn't impossible. Long-distance space travel, and I know it is a huge vision. But hey, it will be powered by biofuels, of course. Who knows, in the next century we may even find a planet much like ours. Oh, the possibilities are endless, but the only way we can achieve it is if you join in. We will uphold the hard work of the masters and make sure the greatness of science is never diminished. Science will be the driving factor for our evolution, and the concept of biofuels paves the way to all those opportunities. We can join hands, embrace sustainability and amazing innovations, and create breakthrough ideas. See what I did there? And it all starts with one spark: biofuels. Well, that is it for now, and I hope you enjoyed the video. My aim was to show you that science has more than just formulas, and that it has and can create many advancements. I also hope you learned something new today. Please leave any questions, comments, or thoughts below, and be sure to, nope, not subscribe, but apply your new knowledge and be the change you wish to see.